Okay, next problem says Aristophanes approximated the diameter of the Earth, about 200 BC. By looking at the shadow of the sun at noon, he recognized that his hometown of Alexandria, so let's say Alexandria is here, and let's say the other city, Cyan or however you pronounce that, is here, and the distance between them is 787 kilometers. And he noticed that the angle between them was 7.2. Now in class, if you want me to go over how he figured that angle out, I will. It's actually pretty clever, and it's real simple too. It involves our alternate interior angles that we learned about in geometry. It's fairly simple. So basically, they just want us to find the circumference of the Earth now, and to do that, we can do 7.2 divided by the total angle. So little angle divided by total angle 360 is equal to little distance 787 divided by total distance circumference. So solve for circumference by cross multiplying and solving, and you end up getting C equals 39,350 kilometers, which is pretty close to the circumference of the Earth. It's pretty good for 200 BC. Okay, the next problem says the diameter of the wheels in your car, including the tire, is 25 inches. It says you're going to drive 355 miles today. Each of your wheels is going to turn by an angle of, let's just use this arc length formula, S equals R theta. Keep in mind this is going to give us an answer in radians that we're going to have to convert when we're done. But the arc length is actually 355 miles. And I know that because if you think about this wheel turning, if it doesn't slip, one turn will give us, the exact circumference of the circle if you were to like unravel this wheel. So the arc length actually is equivalent to the distance traveled here. So that's 355 miles equals the radius, which is 12.5 inches times the angle in radians. Now, I can't have inches and miles. I need to convert one of these, so I'll just convert this to inches. I'll multiply by 5,280 feet are in 1 mile, so the miles cancel, and then I'll multiply by 12 inches are in 1 foot, so the feet cancel. And so basically I have 355 times 5,280 times 12 equals 12.5 times theta. So divide both sides by 12.5. And that gives us our angle in radians, which is 1799424. So it'd be about 1.8 million radians. Now I need to convert that to degrees. I'm going to multiply by 180 degrees over pi radians. So if you basically multiply by 180 divided by pi, that gives you the answer you're looking for, which is this huge number, 1,030,99400 degrees. Okay, that's a lot of degrees that your wheel turns through, but that's the answer we're looking for. Okay, next problem is a little easier. It says that you have an angle between 0 and 360 that is coterminal with this 1620. Well, basically what you can do is divide 1620 by 360 to find out how many turns that is. So you divide this by 360, you get 4.5. What that means is you go around once, twice, 3 times, 4 times, and then another half. So you end up right there. So if you were to go around 4.5 times, you'd end up here, which that's like a 180 degree angle. So coterminal angles are angles that are in the same spot in the unit circle that are technically different turns, but they end up facing the same direction, basically. So if you were to turn around 180 degrees, or if you do a 180 on a snowboard, for example, and do a 1620, you'd end up landing in the same direction for both those angles. The next problem says, in a circle of radius 5 miles, the length of arc that subtends the central angle 5 radians is, here's pi, so there's 3.14, so 5 is like more than that, so it's like, that. We're looking for this arc length. Well, to find it, we can just use S equals R theta. So the radius is 5, and theta, they give us to it in radians, which is good. That's what we want. That'd be 25 miles. The next problem says, are two angles 5 pi over 6 and 17 pi over 6 coterminal? So are they basically in the same direction? Well, they are, and if you want to know why, 5 pi over 6 is like here. Right, because if you divide this up into 6 equal parts for pi, it's 5 of those 6, so it's somewhere over here. Now, 17 over 6 pi, if I subtract 2 pi from that, so I can make this 2 pi over 6, so I make it 12 pi over 6. And that gives me 5 pi over 6. So basically, if your angle, 5 pi over 6, is in any increment of 2 pi, that means it's in the same spot. So if you can add 2 pi to 17 pi over 6 and get back to your angle, the other one, or subtract, then it's in the same. Because what it means is this, it means you go over 5 pi over 6 to get to this angle, and then if you go around another 2 times, or another 2 pi, so that'd be another full circle, you get back to this angle, right? So here's the black one is 5 pi over 6, and the blue one is 17 pi over 6. You go around, 360 and then another 5 pi over 6. So I don't know if that makes any sense, but they are coterminal angles. It's a little tricky with radians. Okay, the next problem gives us a surface of the Earth, gives us the angle at the inside, which is 9 minutes, and then it says the radius of the Earth is 3,960, and the question is how far is that distance right here? What's the distance along the arc? So let's just use S equals R theta. The problem is we need this theta to be in radians. So we got to take this 9 minutes, we got to convert it to degrees first. For degrees, 1 degree is equivalent to 60 minutes. And then we also need to then convert that to degrees to radians, so we're then going to multiply by pi radians over 180 degrees. The degrees cancel. So if you do that, that angle goes in for theta, and the radius is 3,960 miles times this angle right here, which is like 0.00083 repeating about, and then multiply that, don't round in your calculator, just multiply that by 3,960, and that gives you about 3.3 miles. Okay, the next problem says find the distance that the Earth travels in one day around its path around the Sun. So it says it's a circle. Actually, it's an ellipse, but close enough. Let's assume that it's a circle. So we have 93 million miles for the radius. And we're going to travel just in one day. So that little distance right there is 365th of 360 of a full turn, or of 2 pi if we want to be in radians. And we do because we want to use S equals R theta, where this is in radians. So the radius is 93 million miles. Times theta, which in this case is 2 pi over 365. And that will give us our distance traveled, which is about 1600921.19. So this is about 1.6 million miles that we travel a day.